If a motion moves at constant velocity, then the velocity doesn't change. What if the velocity does change? Then it might be getting faster and faster, or the motion can get slower and slower. That's what we call accelerate. Accelerate means getting faster and faster. On the other hand, it becomes slower and slower. We can say it's decelerate, or maybe it's accelerating with a negative value. So first we're going to introduce average acceleration, and then we're going to see the motion with a constant acceleration. And this is also one of the simplest motions along a straight line. We're still sticking to the simplest. After that, we're going to look at examples. Average acceleration. How do we characterize acceleration? You know the danger of adding up and divide, so we don't do that. Instead, we calculate the final velocity minus initial velocity. That's what we call the change of velocity. So average velocity equals to the change of velocity divided by time. And the unit is meters per second square. Square is like a funny unit, right? A square, you think of square meters for area, but meters per second square is the unit for acceleration. So let's look at an example, accelerating positive or negative. What does negative acceleration mean? If a car is moving at 11.1 meters per second, that is almost like 25 miles per hour, which is the speed limit in the residential area. And the car at some point, boom, stopped. Okay, what's the time? Let's say if the final velocity, what time does it take to stop uniformly here? The average velocity equals to, this is the relationship we know, average velocity is change of velocity divided by time. So the time equals to the change of velocity divided by the acceleration. The change of velocity, the final velocity is 0, initial is 11, so the change is negative. What does negative mean? Direction. That means the velocity is moving to the right, but the acceleration is to the left because it's decreasing. And the acceleration is negative 3 meters per second squared. What does negative mean? Meaning the acceleration is backwards. It's opposite the arrow of this. This is the arrow, opposite the arrow of the coordinate system. So this is an example of acceleration. We can see this acceleration is negative, and the negative sign means the direction. How it stopped. Let's look at the others, one of a simple one-dimensional motion. This is the one-dimensional motion with a constant acceleration. So we have displacement, x, initial velocity, v0, final velocity, v, time, and acceleration. There are 5 properties that characterize this motion, 5 properties that describe this motion, 5 properties that defines this motion. If you know these 5 properties, you know a one-dimensional motion along a straight line with a constant acceleration. Only when it's a constant acceleration, uniformly accelerating or uniformly decelerating, then you are having this motion. Okay, so these are the 5 properties. When you analyze a problem, you better find these 5 properties. Maybe some are known, some are unknown. Usually if you use the known information, you'll find the unknown. How are these different properties related? Is the velocity still displacement over time? Wrong. Do not do this. Please do not do this. Do you know why? Do you remember that applies only when the velocity is a constant? In this case, the velocity v represent final velocity, right? There's initial velocity. The velocity is different at every moment, so there you cannot use that average velocity equation. So that needs to be thrown out. That needs to be unlearned. In other words, we need to put that to the left. And here we do not use this. Are you following me? Okay, so please do not use this. Instead, this is how the different properties are related. Out of the 5, this one has how many? 4. Which is the one that's not in this equation? Acceleration. So this tells you how the 4 properties are related among displacement, initial velocity, final velocity, and time. And if you want to see the other four, initial velocity, final velocity, acceleration, and time, which property is not in this? Displacement. Yes, you're right. Displacement is not in this. Another equation. This equation, there's one that's not in this. I'm going to test your eyes, let you find out what's not in this. And another one. Okay, again, this is an observation test. Look at this and find which property is not in this equation. So these different equations gives you how different properties are related. The first equation, you have 5 except which one? Did you say acceleration? Yes. The second one, you have these 4 properties except which one? Like I'm seeing your reaction. Delta x, the displacement. Yes, you're right. Number 3, this is equation for how the properties are related. The 5. Are all 5 here now? They look like there's a lot of terms. They've got to be all of them, right? No. There's one that's not here, final velocity. The bottom one, last one. Which one is not here? It looks like we have a lot of properties here, but if you look at this, time is not here. So each one of these equations represent how 4 different properties are related. Okay, remember the condition for applying this relationship is that the motion is a one-dimensional and with a constant acceleration. If not, you cannot apply. That's the condition. This law has a boundary or condition. When this condition is satisfied, you use this. If not, then you don't. So when we learn the physics laws, you learn 2 things. First, what the physics law is, and secondly, what's the condition for you to apply it. When you know these 2, you will be able to apply these laws correctly. Let's see, how do we translate different things? If a car stops, that means the final velocity is 0. If it says a car or a lacrosse ball or an object, a piece of rock, turns back, that means the velocity was along one direction and suddenly becomes along another direction. That's a change of sign. When the sign is changed, the value at that moment is 0. So when it turns back, that means velocity is 0. Instantaneous motions. This is for calculus, so this is optional for people who only are using algebra. Displacement is a function of time. So here this includes a motion that does not necessarily have to have constant velocity or constant acceleration. So this is a more general case, but that's still one dimension. Okay, so for one dimension, the velocity is a time of time. So that's the first order derivative of the displacement with respect to time. That's velocity. What about acceleration? Acceleration is the first order differentiation of velocity with respect to time, or that's the second order derivative of displacement with respect to time. So this is how, if a motion with varied velocity or even varied acceleration, this is how we can characterize the motion. So we need calculus to handle those motions with variables. Okay, so in conclusion, we have learned how average acceleration is defined, and we have to only use how it's defined. And second is motion with constant acceleration. I remember those equations only apply when the motion is actually a motion with constant acceleration. Constant acceleration means it's not a constant velocity, because if it's constant velocity, then acceleration is 0. It's not a constant acceleration, really. Okay, so this is what we learned about acceleration. There are lots of problems you can actually solve.